Okay, Assalamualaikum everyone. Okay, so today we proceed with our lecture in topic 2, in chapter 2, inverse hyperbolic functions. Okay, as you can see here, we have the theorem of inverse hyperbolic functions that it also can be expressed in terms of ln. Okay, so here you have, let's say you have the inverse hyperbolic sine x. Instead of you write in terms of inverse hyperbolic sine, you also can write down in terms of ln. Okay, so here you have the six theorems for the inverse for each of the inverse hyperbolic functions. Okay, don't worry, this theorem actually is already in your appendix. Okay, so now look at your appendix in page 91. Okay, the formula for the integration of inverse hyperbolic function is from number 17 up to number 21. Okay, so here look at here, you have in terms of ln. Okay, this one also have in terms of ln. Okay, these formulas actually is the theorem that you look at in this. Okay, so now let's look at to the example. Okay, show that inverse hyperbolic sine x will equal to ln x plus square root of x squared plus 1. Okay, when we want to prove some theorem, start with the left hand side. Okay, so now let y equal to inverse hyperbolic sine x, and then this one actually is the definition of hyperbolic sine. Okay, so next, after you substitute the y, you let y equal to inverse hyperbolic sine x, then you will get hyperbolic sine y will equal to x. Okay, so now, okay, at this part actually is like usual quadratic equation, which you need to find the value of x. Okay, so next, when you want to find the value of x, you need to use a quadratic formula. So after you substitute the quadratic formula, you solve the quadratic formula at the end. Okay, yeah, you manage to prove that the left hand side is equal to right hand side. Okay, this is how you show the theorem. Okay, so now we proceed with the next subtopic, which is a differentiation and integration of inverse hyperbolic functions. Okay, so as you can see here, this is the list of formulas for differentiation and integration of inverse hyperbolic functions. Okay, all this formula actually we can get from integral table in our appendix. Okay, so now look at our appendix. Okay, so from the number 17, integrate 1 over square root of a squared plus the x squared dx will equal to inverse hyperbolic over a plus c, or it also can write in terms of theorem, which is a ln x plus the square root of x squared plus a squared plus c. Okay, so now we want to extract the formula for differentiation of inverse hyperbolic function. Okay, so this is what you need to do. Okay, the first step is change all the a's becomes 1, and then all the x becomes u. Okay, so dx now become the du. Okay, when you have the here you have the x. Okay, now change into u, and then a becomes 1. Okay, and then this step is continuous up to formula number 21. Okay, so now the formula for differentiate inverse hyperbolic sine u. Okay, we let as a u. Okay, we assume u is any function in terms of x. Let's say you have the 2x, let's say you have the 2x plus 1, or any function. Okay, so we want to find the formula for differentiate the inverse hyperbolic sine. Okay, so now take whatever function inside the, okay, so now it become the 1 over square root of 1 plus the u squared, and don't forget, whatever it is, you need to multiply with the du over dx. Okay, the similar for differentiate inverse hyperbolic cos u. Okay, so this one, take whatever function inside the integration. Okay, so 1 over u squared minus 1 du dx. Okay, and then for the number 19, okay, for this formula, the differential for the inverse hyperbolic tangent and inverse hyperbolic cotangent will share the same formula of differentiation. Okay, so this one, it become the d over dx, inverse hyperbolic tangent u will equal to, okay, take the function inside the integration, so 1 over 1 minus the u squared du dx. So this formula also same for the d over dx, the inverse hyperbolic cotangent u. Okay, so now let's try the example 2. Okay, find the dy dx for the following equation. Okay, look at B. The question asks you to find dy dx for y equal to inverse hyperbolic cos 2x plus 1. Okay, so now whatever inside the bracket, we need to let as a u. Okay, so now find the du dx first. Okay, so u equal to 2x plus 1, and then du over dx will equal to 2. Okay, so next, differentiate y, we will get the dy dx. Okay, so now differentiate inverse hyperbolic cos. Okay, so now this formula, differentiate inverse hyperbolic cos u. So now look at to the appendix. Okay, the inverse hyperbolic cos, so you will get 1 over square root of u squared minus 1 du dx. Okay, so differentiate. Okay, now you will get 1 over square root of u squared minus 1 du dx. Okay, so as we know the formula, okay, so now we substitute into the question. So dy dx 1 over square root of u squared minus 1. So what is your du dx? Is equal to 2. Okay, so now substitute back your u. 2 over, okay, so our u is the 2x plus 1 squared minus 1. So this is our answer. If you want to expand whatever inside the square root, yes, you can. If you are not confident enough to expand whatever inside the bracket, so you need to stop up to here. Okay, so now let's look at to the next example. Okay, the question want to differentiate inverse hyperbolic cos x over 3x. Okay, this question missing y, so equal, you just need to add equal y. Okay, so your first step is you need to identify either we need to apply the product rule or quotient rule. Okay, so for this case, do we need a product rule? No, because we don't have a product any function here. Do we need apply the quotient rule? Yes, because we have u over v. Okay, so you need to solve for this one first. So u equal to inverse hyperbolic cos x, v equal to 3x. Okay, so now we need to differentiate the u. Okay, differentiate inverse hyperbolic cos, you will get, okay, look at your appendix. Okay, so this is the answer, 1 over square root of u squared minus 1. So 1 over square root of u squared minus 1 du over dx. Okay, so solve for this one first. Okay, so 1. Okay, so now what is your u for inverse hyperbolic cos? So this is our u for inverse hyperbolic cos. So substitute into the formula, then it becomes the x squared minus 1. Next, differentiate the x, you will get 1. Okay, settle for the u prime. Okay, so the next one, find the v prime. So differentiate the 3x with respect to x, now you will get a 3. Okay, so substitute into the quotient rule formula. Okay, what is the formula for the quotient rule? u over v equal to, we always start with the v u prime minus the u v prime over v squared. Okay, so now substitute into the formula, v u prime 1 over square root of x squared minus 1 minus u inverse hyperbolic across x times with v prime is equal to 3, and then everything you need to divide with the v squared, which is the 3x squared, and then will equal to differentiate y, you will get the dy dx. Okay, so now we already got the dy dx. So the next step is try to simplify as much as you can. Okay, so this one, it become the 3x over square root of x squared minus 1 minus the 3 inverse hyperbolic across x over 9x squared will equal to dy over dx. That's it. Okay, so now let's move to the next question. Okay, so our first step is we need to determine either product rule or quotient rule. Okay, so now look at to the 2x times with y. Okay, so let's make it in box. Okay, 2x times with y, inverse hyperbolic assign, tangent y. So do we need product rule? Yes, because you have the u times with v, you have the 2x times with y. Okay, so this one we need to apply the product rule. Okay, so u equal to 2x, v equal to y, so u prime equal to 2, v prime equal to dy dx. Okay, the formula for product rule is we always start with a u, then u v prime plus the v u prime. Okay, this is a formula for product rule. Okay, so now we solve the question. Okay, so this one we need to use a product rule. Okay, so substitute into the formula, u v prime plus v u prime. Okay, you have the equal, differentiate the sign inverse. Okay, differentiate the sign inverse. Okay, so now we want to find the formula for differentiate inverse hyperbolic assign u, where our u is tangent y. Okay, so look at your appendix. So you will get 1 over square root of 1 plus u squared du dx. Okay, copy the formula first. When we differentiate the sign inverse, you will get 1 over square root of 1 plus u squared, where our u here will equal to tangent y squared. Okay, the next one is you need to differentiate u, which is tangent y. Okay, so differentiate the tangent y. Okay, differentiate the tangent y. Okay, if you don't remember, just look at your appendix. Differentiate the tangent ax, you will get secant squared ax. Okay, so now substitute here. So differentiate the tangent y, you will get the secant squared y. Okay, so this one when you differentiate tangent. Okay, so the next one we need to differentiate y. Differentiate y with respect to x, we will get dy over dx. Okay, so now you already differentiate completely. Then the next step is simplify. So 2x dy dx plus a 2y equal to secant squared y over 1 plus, okay, tangent y squared times with dy dx. Okay, so the next step for the implicit, we need to make sure all the dy dx terms on the left hand side, and straight away you can factorize the dy dx. So 2x minus secant squared y over 1 plus tangent y squared equal to negative 2y. Okay, and then the next step, dy dx will equal to negative 2y over 2x minus secant squared y over square root of 1 plus tangent squared y. So this is your final answer. Okay, so that is how you solve the implicit differentiation which involve the inverse hyperbolic sign. Okay, so for the question number, this one is a D. Okay, question D, sine inverse of y equal to 4x squared plus the 2xy. I hope you can try this question.